Alright, going to be a pretty short video today. Got a big reveal coming about all this tomorrow, and we're going to talk about the end behaviors tomorrow in class. But for right now, we have different degrees of polynomials. We're graphing some polynomials, and we have different degrees. We have first degree, second degree, third degree, and fourth degree. And of course, the degree is based on the exponent of the largest exponent. So here the largest exponent is 1, that's of course x to the 1. Here the largest exponent is 2, so the degree is 2. Here the largest exponent is 3, so the degree is 3. Here the largest exponent is 4, so the degree is 4. The standard form of the equations: y equals mx plus b, y equals ax squared plus bx plus c, y equals ax cubed plus bx squared plus cx plus d, and y equals ax to the fourth bx cubed plus cx squared plus dx plus e. And we could go on and we could talk about a fifth degree, etc. Names. Types, names. These are linear equations with first degree are linear, second degree are quadratic, third degree are cubic, fourth degree, there's no name for it, so we call them fourth degree. The number of roots. We said yesterday that the fundamental theorem of algebra said that the number of roots equals the degree. So if the degree is 1, the number of roots are 0. If the degree is 2, the number of roots are 2. If the degree is 3, the number of roots are 3. If the degree is 4, the number of roots is 4. Well, let's look at some of these graphs. Of course, right here, we have a linear graph, a graph of a line. It's from a linear equation with the form y equals mx plus b. Here we've also graphed quadratic equations or quadratic expressions. Here it would look like a parabola, and notice here are my two roots. Here's my one root here, if you will, my two roots. A cubic graph will hit the x-axis 3 times. 1, 2, 3. And fourth degree will hit the x-axis 4 times. 1, 2, 3, 4, or at least they'll have 4 roots. Maxes and mins. This is definitely one minimum right here. This is a maximum. This is a minimum. So there's a total of 2 maxes and mins. Here we have a minimum. Here we have a maximum. Here we have a minimum. So there's a total of 3 maxes and mins. And there isn't really a max or a min as far as the linear equation is concerned. It doesn't turn around at any point, so there is no max or mins. So we're going to look at tomorrow, and we're going to specifically spend some time talking about how things in the equation affect the way the graph looks, and try and come up with some relationships that we can form from these about these types of graphs.